Every winter, a black bear disappears into a den, drops its heart rate from 55 beats a minute to under 10, stops eating, stops drinking, barely breathes, and doesn't move for up to 7 months. When it wakes up, it hasn't lost significant muscle. It hasn't damaged its organs. It just resumes. Now imagine trying that yourself. Stop eating for 7 months. Stop moving for 7 months. You wouldn't wake up thinner. You wouldn't wake up fine. You'd be dead in weeks. So why can an animal shut its entire body down and casually restart it, while doing the exact same thing would kill a human almost immediately? It's not that we never evolved in cold climates. Our ancestors lived through ice ages. It's not that hibernation is rare or exotic either. Bears, ground squirrels, bats, hedgehogs, even some primates hibernate. Fat-tailed dwarf lemurs, one of our closest living relatives, hibernate for up to 7 months a year in Madagascar. That's a primate, a close cousin on the evolutionary tree, shutting its body down for over half the year. If a primate can do it, why can't we? Let's start with what hibernation actually requires, because it's far more extreme than just sleeping a long time. A hibernating ground squirrel drops its body temperature to nearly freezing, sometimes just above 0 degrees Celsius. Its heart rate falls from 200 beats per minute to as low as 3. Its metabolism slows to about 2% of normal. And here's the part that should be biologically impossible. Its blood doesn't clot into deadly clumps, even sitting nearly still for months. Human blood, by contrast, starts forming dangerous clots after just hours of inactivity, which is exactly why doctors force patients to move after surgery. Hibernators have evolved a way to switch that danger off completely. Muscle loss is another wall we can't get past. Astronauts on the International Space Station lose significant muscle mass in just months, even while exercising 2 hours a day in zero gravity. Bedridden patients lose noticeable strength within a week of lying still. But a hibernating bear, motionless for months, wakes up with almost no muscle loss at all. Scientists studying black bears found their muscles somehow recycle waste nitrogen back into protein, essentially feeding themselves from the inside without eating a single meal. Honestly, imagine if humans actually worked this way. Every November, your boss sends one email. See you in April. No meetings, no commute, just 7 months of silence in a fridge you don't even need to open. Sounds incredible until you think about it for 2 more seconds. Imagine missing 6 birthdays because you were asleep, missing an entire year of your kid growing up in one long blink. Waking up and your phone has 400,000 unread notifications and a haircut you don't remember getting. Suddenly it's a lot less relaxing, and then there's the brain problem. In most mammals, dropping core body temperature this low would cause permanent brain damage within minutes. Human hypothermia victims who survive a body temperature below 28 degrees Celsius often suffer lasting neurological damage. Hibernating animals routinely drop below that number and wake up completely fine. Memories intact, no cognitive damage whatsoever. So what's actually stopping us? In 2013, researchers at the University of Cambridge identified something remarkable. Nearly every mammal on Earth, including humans, has the genetic machinery for hibernation already sitting dormant in our DNA. The genes that trigger fat storage before hibernation, that slow metabolism, that protect organs during extreme cold, they're present in the human genome. We're not missing the tools appear to be switched off. That single discovery reframes the entire question. This isn't about humans lacking some ability other animals have. It's about humans possibly losing access to an ability we may have once had, or never fully activating one we already carry. But here's where it gets complicated, because most scientists don't think it's that simple. The leading theory is that hibernation and our specific evolutionary path became fundamentally incompatible somewhere along the way. Human brains are enormous energy consumers, using roughly 20% of your total daily calories just to run, even while you're sitting still doing nothing. A hibernating brain has to be partially suppressed to survive the metabolic slowdown. For most animals, that's fine. For us, an organ this demanding may not tolerate being shut down without permanent, catastrophic damage. Researchers call it a trade-off. We built a brain too expensive and too important to risk hibernating with. Body size complicates things further. Hibernation works incredibly well for small mammals with a lot of surface area relative to their body mass, which lets them cool down fast and warm back up fast. Larger, more complex mammals like humans have a much harder time cooling efficiently, and warming back up without damage becomes exponentially more dangerous the bigger and more complex the organism gets, which honestly might be the real reason. Somewhere in evolution, natural selection looked at the human brain and said, absolutely not. We are not risking that thing in cold storage for 6 months. Clean explanation, right? Mismatch between our brains, our body size, and hibernation biology. Case closed. Except there's a discovery that complicates all of it. In 2020, anthropologists studying 400,000-year-old human bones at the Cima de los Huesos site in Spain found something strange. Seasonal growth patterns in the bones, patterns that closely resemble the bone growth cycles seen in modern hibernating animals. Some researchers now believe ancient human ancestors may have gone through extended periods of dramatically reduced activity during harsh winters. Something closer to hibernation than we ever assumed possible for a hominin. If that's true, it means the machinery wasn't just theoretically available. It may have actually been used and then lost. Which raises the real question nobody can fully answer yet. Did we evolve away from hibernation because our brains made it biologically impossible, or did we simply stop needing it once fire, shelter, and stored food solved the same problem hibernation solves, and the ability quietly atrophied from disuse over hundreds of thousands of years? Right now, NASA is actually funding research into inducing torpor, a lighter form of hibernation in humans for long-duration spaceflight to Mars. Early experiments on rats have successfully triggered short torpor-like states by activating a specific cluster of neurons in the brain. If it works in humans, it wouldn't be creating something new, it would be reactivating something extremely old. So maybe the ability never fully disappeared. Maybe it's still there, buried under one of the most demanding organs evolution has ever built, waiting for the right trigger. Every winter, somewhere in a den or a burrow, another mammal shuts down completely and simply picks back up months later, like no time passed at all. And somewhere inside you, quietly switched off, sits the exact same set of genetic instructions. Maybe we didn't lose the ability to hibernate. Maybe we just built a brain too valuable to risk sleeping through. If your brain enjoyed peeling back a mystery like this one, that's the whole point of this channel. Like this video, subscribe, and let's keep peeling.